Hello, welcome everybody. Just to wake up people, because we're after lunch talk, how many of you use OpenTable? Good. I hope the rest of you that do not show hands start using OpenTable right after this talk. So my name is Pablo Delgado. I work in data science at OpenTable, and we're trying to transform the dining experience for our clients or diners. OpenTable has 32,000 restaurants worldwide. We have seated 760 million diners since we started. We have presence in many countries, US, Canada, Mexico, UK, Germany, and Japan. Originally, OpenTable was only just a transaction site, but now we're moving towards designing an experience for diners. So we will try to get a companion for you before you choose the restaurant, get the experience while you are at the restaurant, and get you also after you have dined on the restaurant. So in order to do that, in order to craft the experience, we need to understand the diners. And for that, we are building a profile, implicit and explicit, of all the signals we can collect and the information you have provided and reviews you have written and ratings that you have given to certain restaurants. And we also need to understand the restaurants. We have metadata about restaurants, but we also have a lot of reviews, and we use those to understand what the restaurants are all about. If they are good for a date, if they are good for family, or if they have a great view, or if they cook the steak at perfection. I'm an Argentinian, so that's very important for me. This is what we have. We have reviews, images, we have a lot of signal. We have also ratings. We have search activity of our users. We have transactions. And so what does it take to make a meaningful recommendation? We have the basic ingredients for that. We have the user metadata, we have restaurants metadata, and we also have the activity between users at restaurants. So we combine them into models. So making a recommendation starts with collecting the signal. We have a wealth amount of logs. We focus on mining the logs since 2010 until 2014. And the logs comes in the form of IS, Internet Information Server logs. And we have to use regular expressions to parse the signal from here. And we basically found out that the search activity or search intention for a restaurant makes more sense. So we have a user restaurant pairs that we collected over the years. The new system we have in place uses JSON structures that we more collect and more easily query and slice and transform. So everyone in the data science team can just jump into some bunch of data and then slice it and query it the way they want it. So this is using Spark SQL, querying JSON. This is a little bit of an overview of the architecture we have. We have users, a stream of activities coming from users, and we funnel them through Kafka throughout our data centers. And we also have the state change of our systems, and we collect those input signals and store it safely in Amazon S3 as immutable JSON. We also transform some of the JSON and make some Parquet files that are binary and more easy to query and aggregate. We also have a Cassandra ring in place to have real-time information. So some information needs to be aggregated and queried in a more a smaller time frame. And we have this query processing layer that it's a logical layer. And what we do is we use Databricks Cloud, the product, to let our product managers, data scientists, data analysts to just go and take a dive into the data and query it, analyze it, and make some models, actually like a big sandbox. And then we productionize some Spark models that will power data products. We're going to talk about the recommender stack by now, but we have other data products that are also being powered by this idea of collecting the data, process it with Spark, analyze it with the Databricks Cloud, and then power some data product. So the recommender systems, we have a collaborative filtering type, and we have a neighbor-based approach to build that. We also have a model-based, neighbor-based, model-based, and we have an ensemble that joins the two. And I will talk about this, and my colleague Sudeep will talk about the content-based and the exploration we have done on the review side, on text, and how we are going to build the final recommender that joins everything together. So in the case of neighbor-based, we have this item or restaurant similarity, and it's just capturing the similarity of restaurants by observing the co-occurrence of diners that have dined at the same restaurant. We compute all the similarities for all restaurants. And then the similarity measure we use is the Jacquard similarity. It's a very simple metric, but it gives you like a set similarity. That's what works best for us. This is a map. I don't know if you can see it from behind, but it's a cluster of common restaurants in the Bay Area, and the center cluster in red is it's a downtown San Francisco, and we have highlighted some of the restaurants. So Cotonia and Foreign Cinema, those restaurants, by the way, are very close to this venue. So if you want to dine on any of those, you can search for it in the app. They're very good. Then for the model-based approach, we use matrix factorization. But instead of using the explicit ratings, that were popular by the Netflix context, instead of having ratings from 1 to 5, we chose to do the implicit preferences. We have data for people rating our restaurants, but it's very, very sparse. So we use implicit preference that it's collecting the transactions, so how many reservations you have in a particular restaurant, plus how many times you search for that restaurant, that it's the intention of dining at that restaurant, and we give it a number of times you try to dine at this restaurant. So this matrix, instead of finding the rating, you try to find the preference of a user for a restaurant, and we find out the confidence of how probably it is that you will go to that restaurant. And you can do that in Spark with the train implicit, ALS. It's already provided. You can use it as is. And this is the equation that is slightly different from the explicit formulation. So we have a C that is the confidence, and P is the preference. So we calculate the error on the preference. And we also penalize with a regularization factor there, so to prevent overfitting. But that gives a very nice model of the preferences. And how do we train and evaluate this? We use precision at K, that it's a metric that's been used in learning to rank. So we collect all the interactions for our users, and we hold out 2 or 3 interactions, and we try to predict those to see if we can, So precision at K, we try to guess, we give a recommendation of top K restaurants that you might like, and we try to see how many of those we get correct from the holdout set. And we do this for one user, but in a loop, we do the mean average precision at k, that is computing the recommendations for every user and having a global number of them. We also have a final model that is the ensemble of the matrix factorization plus the item similarity. And the way we do this is we try to blend it with a parameter called alpha. And alpha, we find for a group, we stratify the users, and we find from a bucket of users that have a number of interactions. We find that alpha 08 is the alpha that gives this model, this combination, this ensemble, the best precision for 6 elements. So the way we do this is the matrix factorization gives you a rank, and item similarity gives you another rank, and we blend the two ranks with this weight mean inverse rank. And we also have found that the alpha parameter is a function of the support. So depending on how many interactions you have, if you have many, many interactions, the model, the pure base model that is a matrix factorization works best for you. And if you have very, very little interaction, you have dyne 2 or 3 times, the item-based similarity works best for you. And if you're in between, a blend between the two models works best and helps out in the precision. And the result is that we craft these beautiful emails that are computer generated, and we recommend 6 restaurants to you. And we have done this over many months, and we always A/B test this, competing against humans choosing the best restaurants to recommend, and we always beat a nice selection of great restaurants. And this is the end of my part of the talk. I'm going to let Sudeep continue with his part.
Thank you, Pablo. Let me see if this clicker works. So if Pablo had a little too many equations in there, I'll have too many tasty dishes to talk about. So just to wake you up and also make you hungry, and so that you go to OpenTable tonight and actually book something. I'll make sure that happens. So basically what Pablo talked about was how we make recommendations using interactions, right? So basically a user goes to a restaurant, gives it a rating, or you search for a restaurant in our system. But beyond this, we have a lot of information in the content that you generate on our system as a diner. So content comes to us in the form of one of the biggest type of content that we have are the reviews that diners leave on our system. Reviews come in all shapes and sizes, so sometimes you'll find a review, it's a 5-star review, but it's only one word, superb, that's it. But sometimes diners are very passionate about their experience at a restaurant, and they'll go and write a very detailed review on our system, like the one you see on the right. It basically just bumps up against the 2,000 character limit that we put there. And most of our diners are like that. They go to fine dining restaurants because they really like to dine out. They really like to go and experience this restaurant from the point they booked it to the point they arrive and they sit and have the experience all the way to the dessert, and they go back and write about this. So there's a lot of information in these reviews. And if you think about it, restaurant reviews are only going to be about a few things, right? So people are going to talk about food and drinks. People are going to talk about ambience, the service they received, the value for money, right? If it's affordable or not. And if they go to these restaurants for special occasions. There are restaurants where people would actually splurge on special occasions but would not go to normally. So if you think about this, because reviews automatically sort of break down into certain kind of themes, it's very fertile ground for doing something called topic analysis or topic modeling. So that's what we do. We basically go and take all the reviews from a certain region, say take all the Bay Area reviews, and then we learn topics. Once we learn topics, we see that these topics fall automatically into some categories that I already showed you. And then what you can do is you can map this topic back to restaurants and thereby summarize what this restaurant is about. And then you can browse relevant reviews for each topic. So you can say, show me only the seafood topic or show me only the views topic for this restaurant because I'm not interested in the live music topic for this restaurant. So this gives us a way of really nicely summarizing a restaurant. So we have used, we have attacked this problem with many different algorithms. And one thing that we found really works well is a non-negative matrix factorization. So here I have the document word matrix, which you break up into a document topic weight matrix, and this matrix T is your topic matrix. So every row in here is as long as your vocabulary. And suppose you have learned 100 topics, and these 100 rows basically are a distribution of our words, each of which is a topic. And I'll show you what the topics look like here. So you can see that on the top left, there is this like very fish and chips, very seafoody topic. And then there's a topic where people are talking about the noise at the restaurant or the view of the Bay Bridge. So this is all San Francisco topics, as you can see. People are talking about the Bay Bridge and all kinds of like wine country things here. There's obviously a big topic which talks about Sunday brunch, the server being helpful or rude, parking being easy or really difficult. And then there's the special occasion topic, which is like, the anniversary of the wedding that people go to. So these automatically fall into categories. And you can basically, if you learn 100 topics, you can just manually go through and basically say which topic falls into which categories. And we basically go and label the topics like that. But once you've learned the topics in one metro, it's very easy to actually label these topics in another metro because these topics always come up with very similar word distributions. So how do you go from topics to insights? So let's say a restaurant has 2,000 reviews. So after you do this topic analysis, you'll find that each review has a distribution of our topics. So if the first review talks about seafood and a beautiful view of a sunset, these two topics will peak. If the second review only talks about the seafood, there is no view topic in there. But in average, after you have summed over all the reviews, you can get a distribution of topics for that restaurant. So now you can say, okay, I know that these three topics, live music, seafood, and view, is what really summarizes this restaurant for me. And so we do this for a couple of my favorite restaurants in San Francisco. So there is this Brazilian steakhouse, Espetus Churrasqueria. It's like a few blocks on Market on that way. And it's obviously a churrasqueria, so there will be a lot of like meat-related topic here. But what's nice is that, because we mine this from the reviews, people actually talk about how amazing the salad bar is in that restaurant. So we can surface something like the salad bar being really good. So there's a salad bar topic in there, if you can look carefully, that is really like people really like. And also people go here for celebrating anniversaries, and so this is a special occasion place which is not only good for meat, but also has very good salads, right? And this is something you cannot really grab from the metadata of the restaurant. The restaurant's description doesn't say that, we have amazing salad or whatever. And then again, if you go to another place, which is like Fog Harbor Fish House, which is at Pier 39, they have excellent views of sunset. I always take my friends there. So they have very good like crab and seafood, and you see these topics becoming really important in this restaurant. And then you can also, basically get these nuanced views of the restaurant. Like, people talk a lot about how they enjoy the sunset view from this restaurant, and there is no way you can get this information from the metadata of the restaurant, so unless you actually dive into the reviews. So basically, once we learn all these different features of the restaurant, then we can actually extend the models that Pablo described to actually include these different other dimensions. So we already know something about the restaurant and user interaction, but we do know now a lot more about the restaurants. We know which things the restaurant is known for based on the reviews. We also know sort of their cuisine range, the time they're open, all those things. And then we also know, we also could include the context, whether like the guy who really likes to go for upscale French places on special occasions may be happy with a mediocre Chinese restaurant on Friday because it's busy, right? So getting all this information in, so basically getting the time of the day and day of the week information in, can be done in a very nice formulation, which is these factorization machines. So I'm not going to go into the details. You can basically go and look in the paper that I've referenced here. But essentially, you serialize out everything you know about the user, everything you know about the restaurant, and everything that's the side features you know about the interaction and the context into this one row, and then you're trying to predict how likely is this user to transact at this restaurant. So we are actually trying to implement this right now. It's a work in progress, so we'll implement this in Spark, and sort of stay tuned to see what comes out of this. So I want to switch gear a little bit about what else we can also do about with our data, which is textual. And one thing that's kind of really interesting and close to my heart is a sentiment analysis, because you express sentiments in reviews, and sentiments have value, but it's a different story how you can make a product value out of the sentiments, right? So first thing you can do is you can basically throw in all the positive reviews and negative reviews, and basically, you know, this is, if you recall the keynote from Ali on yesterday, this is basically like deja vu for me, because he was basically going through this exact same exercise, except we use our own reviews. So we basically take our 5-star reviews and 1- and 2-star reviews, we create a balanced set of the two, and we basically run logistic regression. And out comes this model, which is very good at predicting on a sentence-by-sentence basis what rating a person would be giving if they wrote that review. So basically, here are some examples like, this place was too noisy for me and my girlfriend. It correctly predicts that the sentiment is 0. In this case, there's a negative sentiment. So how can we use this in the product? So suppose you go to a restaurant and we already know sort of what dishes people talk about a lot at this restaurant. So this is a restaurant where this dish called goat stew is very popular. But if you wanted to show the user just a mention of the goat stew from a review, which carries a lot of positive sentiment about it, it's not a trivial problem, because these mentions are buried deep inside the reviews. So what we did was we plucked the sentences that contain this dish, then we scored each candidate sentence according to its sentiment, and then we choose the one that has the highest sentiment as the candidate sentence that I want to show on your app. And there are some rules around here, because there is only so much real estate on an iPhone or a mobile phone, so we have to work within certain constraints of rules, but this turns out to be a really great way of actually giving you ground truth that not only people talk about this dish, they talk about the dish in this way, right? So basically, it starts learning all these beautiful things like to die for in case of food is actually a really good thing, right? So crispy, moist, tender, these kind of words actually fire very positive emotions when you're talking about food. Even it knows that yum is a feature that you should learn when you're talking about sentiments. So I would like to go in a little bit of exploratory space now. So this is this algorithm. I don't know how many of you have used this recently, but it's an old algorithm, but it's coming to focus more recently because we have data, very nice data to show some really nice examples. So this is word2vec, which essentially learns vector embeddings of words. So essentially, you can think of, given a word, it's trying to predict the words that surround it. And by making it go through that exercise, you are basically learning an embedding of these words in a higher dimensional space. It's like, say, a 100-dimensional space. And once you've learned how to put the words as vectors in this vector space, you can start asking several questions. One of the easiest questions you can ask is that what are the other vectors that are closest to this vector, which is, in word2vec language, it's called synonyms. And this is implemented in Spark, and this is some results that we actually are pulling up from Spark. Gensim is another library which is Python-based. It's also very rich. So for most of the things I'm showing here, we do both Python and Spark, but obviously when you go to big data scales or the 25 million reviews, we move to Spark, right? So anyway, there's an example of a dish called cioppino. I don't know how many of you have tried it. So it's a seafood soup that's very popular in San Francisco, and it's actually probably only found in San Francisco. But when you ask word2vec, give me the synonyms for cioppino, the first thing that comes up is a bouillabaisse, which is also a seafood soup, which is found in the south of France usually. And then it goes into all the ingredients of cioppino, right? So this is really incredible how, by looking at how people are describing these dishes in reviews, it comes up with all the things that this dish stands for or include or can be paired with. So you see, like, cioppino is usually served with things like fettuccine, linguine, so it actually comes and picks those words out of this huge vocabulary of words that we have. So can we actually do something in the spirit of man, woman, king, queen in the food world? So I asked Word2Vec, okay, take the vector representations of halibut and chardonnay, because they pair well. White wine pairs well with fish. And then I asked, okay, so then what should pair with lamb? And it answered Zinfandel, not bad. So I don't think we can actually replace the sommelier yet, but Word2Vec shows promises in this land. Here's something which is even more exploratory that we're trying, which is we can learn the vector representation of a restaurant. So suppose I like this steakhouse in downtown SF called Harris's very much, but now I want to add some features to it. So I want really the experience that I have there, but I want a patio. So what I can do is I can take the vector of patio, I can add it to the vector of the restaurant, and here comes a recommendation, which is a patio at Las Sendas. You go and say, I want live jazz in my steakhouse. So you add that, and it comes up with a very good candidate. You can do the same with this, I want scenic view. So this is a whole new way of making recommendations, right? So here, the only thing you're leveraging is the reviews, the content. And because from all these other models, I already have scored every restaurant according to your preferences, I can then take those recommendations and add this new dimension to it. Say, like, today, I'm going to give you recommendations of things that you really love, but also I want to give you a thing that has scenic view to it, added to it. So this is a really nice way of translating recommendations according to a concept. And then what you can do is also say, here is a restaurant, give me all synonyms of the restaurant. And usually, because we have learned this over all restaurants in the world, so it does not automatically give you restaurants in your own city. And that's a great thing. Because suppose you like Akiko's, which is a sushi restaurant in downtown San Francisco very much, and you traveled to Chicago, I can ask Word2Vec, based on the reviews, what's the closest synonym of that restaurant? And it will give me a recommendation, which is almost a twin of Akiko's, based on how people talk about it, in Chicago. So I'll be very happy with such recommendations. So these things are, again, very at the exploratory stage. And obviously, we'll see how they actually fare in the wild. We haven't done any experiments with these yet. But this is really opening up a very new way of doing recommendations. So I hope combining Pablo's talk and my talk, you get a sort of a holistic idea of how we're trying to leverage every bit of data that we have in order to make your dining experience really enjoyable. So I hope you like the talk, and you can shoot us emails later. Or Thank you.
So thank you again. Really interesting presentation. Quick question. So let's just say you've learned about a user, right?
Right.
Maybe they wrote lots of reviews. You obviously know the restaurants. As you said, you vectorize those. So when you're trying to make the recommendations, in general, do you do them on the spot every night, or is it, do you basically do batch recommendations and maybe store it in a database, data store of some sort, one for each user, or how do you sort of go about doing that once you already know the user and you know the restaurant?
Yeah, so maybe.
The way we are doing this is, storing all possible recommendations for all users. It takes too much space. We could do that. Can you? No. We could, hola. We could do it, but it takes too much space. In contrast, we store the two matrices, the factor matrices. So it's like a whatever million users we have, and the rank 50 times another matrix that is the number of restaurants we have times the rank 50, and these two matrices are much smaller to store. And then we do the product multiplication on the fly when we serve the recommendation. For the email campaign, though, we have the luxury to pre-compute everything in a batch way and output a file that it's been fed to the mail system to send out the emails.
Yeah, and we haven't made this productized yet, but these vector additions, like, I want something like this, but romantic, that can be also done on the fly. It's like very compact representations of these concepts. So.
Hi, a question about the last piece of the presentation.
Right.
Is this going towards, can I do a search? Say, look, I'm going to New York. I like this place. Give me give me places that are similar. Is this possible? Is this what you guys are? Because that seems a very low-hanging fruit that nobody has cracked yet.
Right. So you know, we haven't. So this is something, you know, we just came up with and we presented to our team like very recently, but we haven't really thought through all kinds of like ways this can actually be used in the product yet. But that obviously is a great way to surface this to a user. It's like, you know, we know that these are the places you like,
So
and then
say you have we have collected your history at dining at San Francisco. So when you move to a different city, we just need to shift all the recommendations that we have from San Francisco and translate it to synonyms in New York. And then we can provide you some.
Right.
We
that's
need
like,
to explore as well.
And that's like one way of doing recommendations. On top of that, we have all the other ways. So we can also think of ensembling these recommendations in a very clever way.
Or let you select. Maybe you can have a UI
you can have
where
like
you
a
can
dial.
select one restaurant that you like, and then move to a different city and see what comes out.
So one of the problem with topic modeling, I guess you must have used LDA, right? So the problem with that is the topics in like when you run twice, like those are not in the same order, right? So how do you deal with like creating the new topics that are created? Do you like somehow measure the similarity between the topics that you generated previously and the new topics that you generated?
Yeah, so basically if you have more content, there's more reviews, the topics will slightly change, even if you keep the initial seed. So basically so because we don't use LDA, we use non-negative matrix factorization, there's this initialization of the method that's very important if you want to get interpretable topics. So it has to be initialized with something called NNDSVD. And obviously there is stochasticity in there. So if we get more reviews and ran, the topics will slightly change. But the topics usually turn out to be similar enough that you can go and relabel them with the same label. And that also happens between Chicago and New York and these kind of like different cities. But we find like really nice regional nuances sometimes. So basically like in the US, we find a lot of people talking about wine pairing, whereas in the UK, we find people talking about wine matching. So these kind of things actually come out. But the topics are still similar enough that you could label them as a wine topic.
Hi. Hi. So my question is about the skewness of data usually around restaurants. There are 10% of restaurants which are very popular, and you have like 90% of activities around those restaurants, and then the long tail, the 90% of restaurants with just a few reviews or 2 searches per month. So how, did this affect your like item-based recommendation and stuff? Because it's very hard to deal with that long tail.
Yeah, so that was the main motivation of going into content-based recommender, because although restaurants might, may have very few reviews, very few ratings, they often tend to have a lot more reviews. And also metadata is, of the restaurants are just basically unused if you're using just interaction data. So I did not talk about it here, but there is a way of doing, like a Bayesian information retrieval kind of recommendation where you use all the metadata and all the topic weights to make recommendations. And those, so this is, if you go to the literature, this is called Bayesian sets. So basically you're starting with few examples of places you went to, you're trying to complete the set, and in that mechanism, there is no bias for restaurants that have higher ratings or lower ratings. Okay, this is basically just going off of what you know about the restaurant's content. And that tends to pull up a lot of these long tail examples into your sample. So we actually blend those together, not always, but sometimes, and so that you can basically go and explore a new thing, right? This is very interesting. Otherwise, you'll get pigeonholed into the same kind of restaurants, right? So for any recommendation systems, doing something like that, which picks some examples from the long tail and shows you that and see how you react, is the way to keep it interesting. And we do that with the content-based.
Thank you.
Okay, great. Other questions? We can take some other questions outside for follow-up. Thank you very much.